Welcome back everyone. This particular video is about a problem or a situation I call double lifted data. Disclaimer, it's not an official name, it's not a formal name, it's just I call for my convenience and or my pattern matching brain. So, what I wish to do in this session is to establish what is double lifted data and discuss various ways you can attack the problem. So first of all, let's understand what is double lifting. Now we have an int x, and this is lifting. You have an integer which is now lifted into an int option. So y is an int option, no surprise. And then we move further and pack it into a result. So z becomes a result of int option, and the other side, the other case, the result, so the error case is not known, so ignore that. It's still waiting for some application before resolving the generic part of it. But z at this moment is double lifted data, int which then goes into an option which then goes into a result. Now, before I start discussing the problem with this and the ways to handle it, let's first of all understand how you may end up in this situation practically, because this you will never force yourself to do this, but how you may end up in a situation where you have double lifted data. So when I first encountered double lifted data, I wasn't sure that it may happen so frequently. So let's just take a very simple example. Let make db query. So I'm just writing a function which runs a query, and it's kind of useless function because you can't just have a query and run it out of thin air. But let's assume that this is the case. What are the possible outcomes of this function? The possible outcomes are failure, network failed, db failed the query because the query either was malformed or we are using some bad column name, collection name, table name, whatever. Let's assume that the call was successful and we had data. And the third case, the call was successful, but there was no data. These are the three possible outcomes. In this case, you are talking about an error case. Result, error case. In this case, you are talking about the OK case and some case. And I'm categorically talking about a query which will not return more than one record. So make query for one record. I'll complicate it in the second example. So just let's focus here for a while. So if the query was successful and we received some data, OK case, and within the OK case we're talking about the sum case. And if there is no data, we're talking about OK case because the query worked well. There's no error in making the call, the database didn't reject the query, and so on and so forth. But in this case, we're talking about none. Similarly, let's talk about another function for many records. This remains same. This on the other side becomes OK and a sequence or list or array or whatever your implementation is. If you find if there is more than 0 records, you will have something in the container, one of these. If you don't have, you will have an empty container, but you will not run into this case. But that doesn't matter because the double lifting is happening between the option and the result. So these are very simple examples of how you may run into situations where you have double lifted data. So let's proceed with from here onward. That this is, and let me call it double lifted, and let me just simplify it by saying OK sum 1. So we have sum 1 which then goes into OK, and just verifying we have a result of int option. Now let's write our dear mapping function. Let add 2 x equals to x plus 2, and I have given you so many examples of mapping with option and with result that you just focus on this issue, not how data is packed inside a container, how can mapping happen. You just focus on what you need. So if at this point you say result dot map add to double lifted data, let result equals to, and you run into an odd error. Now let's try and break this down. Why is this happening? It's happening because you are assuming it's when you start dealing with so many layers of abstraction or multi-level lifted data or very complex situations where functions are moving from here to there, it's difficult to quickly figure out what's going on. It's a slow process. This skill one develops with time. So when we are saying result.map and we are saying add to, the signature of add to is it takes an integer. In other words, result to map add to whatever is expected here is of type result int anything. Doesn't matter what's on the right side or on the error case, because mapping for result only deals with the OK part. When you are saying use add to, this function is assuming that this data is of type result int and then whatever. But that's not the case. You have result int option, and that is the problem of double lifting. The moment you have double lifting, your regular functions cannot be combined with map and bind and so on and so forth. So I've talked about 3 approaches which are loosely put. They are all the same, but let me give you the very first example. Is that I'll talk about all the 3 approaches and the ifs and buts associated with all of those. So let me first of all write my own function. Let add to for option, and I'll just copy it. Yeah. And let me call it add 1 or add 2 for option equals to this. Yeah. And problem solved. Let's understand why this worked. This is a function. Let's look at the signature of this function. It takes an int option and returns an int option. Now look at it from the result.map container side. In this example, the result contains int option. So if you have a function which takes an int option and produces an int option, for result.map, it's a non-elevated function. In other words, if you have an int option and a function which is int, from option.maps perspective, this is a function which is purely dealing with non-elevated data. Now that you have result of int option, comma, whatever, and if you have an f, a function which does int option from result.maps perspective, This is a non-elevated function. I know that kind of breaks the discussion we had in past, what are elevated functions and what are not. But you have to also look at it from the container's perspective. It can't be just whether you are dealing with primitive data types or elevated data types. So you have created a function which is dealing with at option, which is dealing at option level. It's an int option function. So wrapper takes an option, produces an option, and this works. And you can replace this by a lambda fun x equals to x. No big deal. This approach is technically speaking perfectly fine. There is nothing wrong with it. The only problem with this approach is that for each map and bind function, either creating such a function or using such a lambda is a massive overhead. Is the burden that burden is yours, and I'm not fan of burdens that shouldn't be my burden. Carrying that to my code, I'm not a fan of such an approach. So now let's look at the second approach, which is practically speaking a cousin of this approach. And before we proceed with the second approach, please recall option.map, result.map, option.bind, result.bind. These functions can also be used as function lifters. If there is any doubt, please refer to one of the previous discussions where I talked about the the containers and the very basics of map and bind functions. It's in one of the previous videos. I explained, and this is also on the blog. If there is any confusion, you can revisit. You can use option and bind to create functional lifters. So to quickly give you an example, if f is this, if you have f, a function which does int to int, your typical use case is option.map f and whatever, some option value. If you partially apply f, if you do just this much, you end up with, let's say, a function called g, which is int option. And this is what the whole category theory calls, I believe the right terminology is elevation, but as I explained, or as I expressed myself earlier, I stick to the term lifting. So we have f, and with this technique, the partial application of option.map, we are getting an elevated or lifted version of it. Okay, so this can be written as, and you can replace this with this. It's a completely different way of doing exactly the same thing. In one case, you have a full-blown function. In the other case, you have a partial function. When you had a full-blown function, this parameter was required here. When you made it a partial function, that parameter will be eventually supplied somewhere in the function call, chain, lifecycle, whatever. So this is what I've explained here. Exactly this partial application, or you can even say partial application like this. It doesn't matter. It's all of these are different ways of doing the same thing. Now these two approaches, like earlier, are perfectly fine. Technically speaking, they are absolutely correct. There's no flaw, except again the burden is yours. When I encountered this situation, I wanted to write this or something like this, something similar. I did not want to pollute my code with either pointless wrapper functions or this partial application. I'm not against partial applications, but I'll do partial application when I need to do partial application. I'll not do partial application when I have a straightforward use case. Okay. So now that this forces us to the third approach, which is the approach I actually wanted to highlight, because in future we will use such an approach. Because double lifted data is not the only problem statement. There are lot of times when you will create your own functions for either the established container types or the new containers. So what I'll do is I'll just let me copy a piece of code from here. Ideally it should go into some other file. So what I'm doing is I'm just getting rid of this and I'm creating two functions. Okay, since I'm getting rid of the module, when I call this function, please assume I am saying result.optmap, and don't be confused by the fact that how can I add functions in result module. I'll talk about it, how you can extend existing types and add functions in the existing modules and so on and so forth. So wait for it to happen. I have created two functions, categorically calling them optmap and optbind, and I put them in result module. So when you say result.map here, you are saying map, which is in the world of result. So when you're saying result.optmap, by convention, by naming, what I am telling myself or the programmers around me is that now I am dealing with double lifted data. So before I move forward, let me just do this optmap, and we are done. That's it. The overhead of, and this is again the whole partial application approach which I just talked about. Similarly, I have created a bind. Don't be bothered by the fact that in both the cases I am calling result.map. I'll just explain quickly how these two functions are working, out of which this should be pretty clear to you, because this is the example that we just built. So I'll talk about this one in 2 minutes. So this particular bit, eventually when everything is properly laid out in modules and files and whatnot, this is what you will write: result.optmap add 2. That's all. Since the data is double lifted, there has to be something which will take care of double unpacking and whatnot, and double packing while returning. But I didn't want that burden to be owned by the outer layers, where I am stitching the business logic, where my focus is achieving the goals with least amount of code, with least noise, with least pollution and whatnot. So this is how I approach writing a lot of functions to short circuit existing techniques and existing function calls. Now I quickly cover what I have done here. So just like optmap, I have created an optbind function, which takes a binder at real level, which is a function which will take real data and produce elevated data. In this case, this binder should take real data and produce an option. Now, the reason I am using map in both the cases is because from result container perspective, these are all mapping functions. In this case, this is producing an option of int, and in this case, this is also producing an option. And remember, a little while back, I gave an example in comments down below that is a function dealing at real level or elevated level or with lifted data also depends on what the container holds. So because we are dealing with double lifted data, you are dealing purely at mapping level. Okay, more I'll explain later as we create more and more complex functions and create more comprehensive libraries of ours for handling daily or implementing daily utility functions. So hopefully it will be more clear. That's all for now. See you in the next one.